Archaeologists working in the UK and Germany have come across rare examples of what look like ancient wooden spears that would have been used by our ancestors around 400,000 years ago. But scientists were pointedly stuck on whether these weapons were just for poking or if they could have been thrown like javelins. To find out, Annemieke Milks built replicas of the original spears and asked 6 experienced, sharp-eyed javelin throwers to see if they could throw them. I'm Adam Murphy, and she told me how they got on.
We made a couple of replicas of one of the spears, and this is a spear that tapers at both ends with the balance point in the front half of the weapon, so it looks like it could have been designed to have been thrown. And we asked 6 male javelin athletes to throw the spears, and we wanted to test a couple of things. We wanted to understand what their accuracy range might be, so what are the accuracy rates at a series of distances. And we also wanted to understand what kind of velocity, and therefore kinetic energy, they would hit a target with. And so we also filmed both the release velocities as well as those impact velocities at the target so that we could understand the relationship in flight between release and impact and how that might relate to the different participants and experience or body mass. So we were able to take a fun approach to try and understand how these weapons actually work.
And how well did they hold up?
Well, they did a lot better than the current estimates of thrown spears in general, which have been suggested for quite a long time to be limited to about 5, maybe as much as 10 meters. And we discovered that the athletes were able to hit the target up to 20 meters.
And did they hit hard enough to be useful as hunting spears?
We discovered actually that because of their mass, they weigh about 800 grams, which is actually the same as a male Olympic javelin athlete would throw with. And so, first of all, we understand that the mass is not a limiting factor if you have an experienced thrower for a spear like this. And in fact, ethnographically, we know that people more recently, they threw much heavier spears than that. The Tiwi, for example, threw very heavy spears. And so because the impact velocities were reasonable, we discovered that the energies with which they hit a target when they do hit are actually very high, much higher, for example, than a bow and arrow would hit a target with. Now, there are other things to think about, like what is the tip material and how would that impact into an animal. But in terms of our broad categories of how much kinetic energy you need to kill a large animal, yes, we certainly see that these are potentially effective weapons on big animals.
How can you determine that these things are throwing spears and not sticking spears?
We never know for sure, looking into the deep past, exactly what our human ancestors were doing with their technology. And that's one of the reasons we need experimental archaeology to help us kind of understand the possibilities with these weapons. And now there are some extensions of studies that we can do, and one of these is to start to look at the animal bones that we see these early and later Neanderthals hunting and butchering. We can start to look for impact damage to the bones, and potentially even to these very rare wooden spears, to try and understand whether we might be able to identify throwing now that we understand the impact energy.